So the topic is on-device subspace learning with chest X-ray screening. And so, I mean, the broad context is smart clothing and medical devices that are sort of wearable. But the main contribution here is the application of something that we refer to as the SOC transform, which we did not develop, but this is, to my knowledge, the first time it was applied for this particular application. It's been used in other medical applications such as heart structure and so forth, but so you'll see SOC is an abbreviation, it's not a name. As you can see, subspace approximation with augmented kernels. What that will mean will become clear shortly. Okay, so introduction to the medical aspect. In the US, you have 2 to 3 million people with pneumonia, and it can be caused by several different, it just means an infection of the lungs. Primarily it's bacteria and viruses, sometimes also mycobacteria such as tuberculosis. Fungi is generally restricted to immunosuppressed patients. Parasites, you have primarily Strongylides and Ascaris, so roundworms. And the gold standard right now for diagnosis is still the chest X-ray. But I want to emphasize this phrase at the bottom, pneumonia-like phenomena, because properly speaking, pneumonia is only when you have an infectious agent. And there are many kinds of conditions that look like pneumonia from an X-ray perspective. So pneumonitis could be caused by anything from, so for example, workplace things like silicosis, vaping, drug interactions, things like that. And plus you have other diseases that also replicate, that present very similarly, such as Legionnaires or SARS, et cetera. So we're restricting ourselves, to basically image classification and detection of what looks like pneumonia, but that's not enough for a diagnosis. So I just want to be clear that this is not a full diagnostic tool in that sense. Okay, so the need for a low-cost screening tool, and this would just be sort of the first stage. And then after this, you kind of have to move on to other things to try to rule out other potential, differential diagnosis. But essentially, you have a lot of situations where you have nonprofit organizations. In our own, nearby, there's a homeless shelter in Nevada that has this kind of problem where they have no funding and they'll take anything. Underserved, underprivileged areas, that's a very big problem because most of the time when we're talking about machine learning, you have reliance upon some cloud providing you the ability to do these kinds of, I send it up there and then it spits back a response. But what if you don't have a reliable internet connection? Are you just going to shut down the entire operation? So that was the basic idea behind this project, is to make it so that it wasn't dependent upon internet access and was also still just as convenient. So basically, this is what your chest X-ray would look like. So, your monochrome bone is in the air in between, and you're looking for fluid. Again, that could be other things. That could be a pulmonary edema, pleural effusion, whatever. But in any case, you're looking for just certain marks of the inflammation in the sacs and so forth. So this is essentially what we're working with. We were working with a Raspberry 3 Pi for this sort of proof of concept. And so the idea is to be able to have, on one hand, the image classifier, and then be able to make it into a portable X-ray system. And then you just, one or the other, it's either healthy, not healthy, and then if it's positive for an abnormality, then of course that's another issue, and that would be the next step. But that would be beyond the scope already. So as you can see, bacterial versus viral in the example here. Okay, so traditional convolutional neural networks. This is sort of, I assume most people here are familiar with this. have the feed forward, the back propagation, and then you have to learn, you have to learn it against with all the errors. The problem is that this is very CPU intensive, and then so for portability purposes, this is no good.